we discuss on electronics 5 basic points. 1. Introduction. 2. Branches of electronics. 3. Electronic devices and components. 4. History of electronic components. 5. Types of circuits. 6. Construction methods. Number 1. Electronics. Electronics is the science of controlling electrical energy electrically, in which the electrons have a fundamental role. Electronics deals with electrical circuits that involve active electrical components such as vacuum tubes, transistors, diodes, integrated circuits, associated passive electrical components, and interconnection technologies. Commonly, electronic devices contain circuitry consisting primarily or exclusively of active semiconductor or supplemented with passive elements. Such a circuit is described as an electronic circuit. The science of electronics is also considered to be a branch of physics and electrical engineering. The nonlinear behavior of active components and their ability to control electron flows makes amplification of weak signals possible, and electronics is widely used in information processing, telecommunication, and signal processing. The ability of electronic devices to act as switches makes digital information processing possible. Interconnection technologies such as circuit boards, electronics packaging technology, and other varied forms of communication infrastructure complete circuit functionality and transform the mixed components into a regular working system. Number 2. Branches of electronics. Electronics has branches as follows. Number 1. Digital electronics. Number 2. Analog electronics. Number 3. Microelectronics. Number 4. Circuit design. Number 5. Integrated circuits. Number 6. Optoelectronics. Number 7. Semiconductor devices. Number 8. Embedded systems. Next point is which is in. Number 3, that is electronic devices and components. Electronics technician performing a voltage check on a power circuit card in the air navigation equipment room aboard the aircraft carrier US Abraham. An electronic component is any physical entity in an electronic system used to affect the electrons or their associated fields in a manner consistent with the intended function of the electronic system. Components are generally intended to be connected together, usually by being soldered to a printed circuit board, PCB, to create an electronic circuit with a particular function, for example an amplifier, radio receiver, or oscillator. Components may be packaged singly, or in more complex groups as integrated circuits. Some common electronic components are capacitors, inductors, resistors, diodes, transistors, etc. Components are often categorized as active, e.g. transistors and thyristors, or passive, e.g. resistors, diodes, inductors and capacitors. Number 4. History of electronic components. Vacuum tubes, thermionic valves, were among the earliest electronic components. They were almost solely responsible for the electronics revolution of the first half of the 20th century. They took electronics from parlor tricks and gave us radio, television, phonographs, radar, long-distance telephony and much more. They played a leading role in the field of microwave and high-power transmission as well as television receivers until the middle of the 1980s. Since that time, solid-state devices have all but completely taken over. Vacuum tubes are still used in some specialist applications such as high-power RF amplifiers, cathode ray tubes, specialist audio equipment, guitar amplifiers and some microwave devices. In April 1955 the IBM 608 was the first IBM product to use transistor circuits without any vacuum tubes and is believed to be the world's first all-transistorized calculator to be manufactured for the commercial market. The 608 contained more than 3,000 germanium transistors. Thomas J. Watson Jr. ordered all future IBM products to use transistors in their design. From that time on transistors were almost exclusively used for computer logic and peripherals. Number 5. Types of circuits. Circuits and components can be divided into two groups, analog and digital. A particular device may consist of circuitry that has one or the other or a mix of the two types. A. Analog circuits. Main article, Analog Electronics. Hitachi J100 Adjustable Frequency Drive Chassis. Most analog electronic appliances, such as radio receivers, are constructed from combinations of a few types of basic circuits. Analog circuits use a continuous range of voltage or current as opposed to discrete levels as in digital circuits. B. Digital circuits. Digital circuits are electric circuits based on a number of discrete voltage levels. Digital circuits are the most common physical representation of Boolean algebra, and are the basis of all digital computers. To most engineers, the terms digital circuit, digital system, and logic are interchangeable in the context of digital circuits. Most digital circuits use a binary system with two voltage levels labeled 0 and 1. Often, logic 0 will be a lower voltage and referred to as low, while logic 1 is referred to as high. However, some systems use the reverse definition, 0 is high, or are current-based. Quite often the logic designer may reverse these definitions from one circuit to the next as he sees fit to facilitate his design. The definition of the levels as 0 or 1 is arbitrary. Computers, electronic clocks, and programmable logic controllers used to control industrial processes are constructed of digital circuits. Digital signal processors are another example. Building blocks, logic gates, adders, flip-flops, counters, registers, multiplexers, Schmidt triggers, highly integrated devices, microprocessors, microcontrollers, application-specific integrated circuit, ASIC, digital signal processor, DSP, field programmable gate array, FPGA. Number 6. Construction methods. Many different methods of connecting components have been used over the years. For instance, early electronics often used point-to-point wiring with components attached to wooden breadboards to construct circuits. Cordwood construction and wire wrap were other methods used. Most modern-day electronics now use printed circuit boards made of materials such as FR4, or the cheaper and less hard-wearing synthetic resin bonded paper, SRBP, also known as Paxoline.